Hi, this is Mrs. Cribb. Today we're going to go over mathematics and measurements from your Chapter 3 notes. So pull out your Chapter 3 notes if you haven't already done that. I also am going to go back and forth between the notes and the Prezi, so just be prepared for that. You also might want to pull out your targets so you can see what targets we're covering while we go through this. So math and measurements. First of all, I'll give you this formula right here for density. Density is mass over volume. Mass is measured in grams, and volume is usually measured in milliliters, but it could also be measured in cc's or centimeters cubed. A milliliter is a centimeter cubed. So if you write the word centimeter and cubed, you see it starts with a C and another C. That's where a cc comes from. So usually if you use a centimeter cubed, you're talking about solids for the most part. And if you use milliliters, you're talking about liquids. Or oftentimes if you in the hospital, they talk about give me 4 cc's of, I don't know, something, and they mean milliliters, okay? Now remember, if I write it in your notes, you should be writing it on your paper as well. You can see it says see additional rules for sigfigs, significant digits, and how to use them on those two pages, 66 and 67 in your textbook from the BJU 4th edition. But we've already we're going to go over these rules, and I'm going to write out things for you. First of all, we're going to talk about adding and subtracting. The rules for add and subtract, they are the same rules. And what we do is there's two ways to do this problem. We can do it horizontally. It says example problem, add this many grams and that many grams. Okay, so 1.008 grams plus 16 grams equals. This is the horizontal method. You could also do it vertically. You could say 16.00 and 1.008. Okay, now notice that I lined up the place values. The decimals are lined up, and the ones place is lined up. Everything's lined up. So with addition and subtraction, what you're concerned with is precision. So addition and subtraction, you look for the least precise number. Look for the least precise. And you have to remember, what is precision again? It's how repeatable something is, or how many decimal places it has. So if I have 2 grams and I have 0.1214 grams, this one is precise all the way down to the 10,000th place. This only goes to the hundredths place, tenths, hundredths, thousandths, 10,000ths. So this number right here would be the least precise. And so when you're adding and subtracting, you got to look for that. So I look at these numbers. How many significant figures does this number have? Well, there's a decimal point. The point is present. We come in from the Pacific. It has 1, 2, 3, 4 sig figs. So all of them are significant, and the precision goes all the way to the tenths, hundredths, thousandths place. This one also has 4 sig figs because we come in from the Pacific and we count 1, 2, 3, 4. But this one is only precise to the hundredths place. So when I add these things up, I'm going to get 1 and then a 7.008. And I can do it over here as well. 17.008. Okay, now I look at the precision. That the answer can only be as precise as the least precise number. So this number is the least precise. And it ends in the hundredths place. So my answer has to end in the hundredths place. So after I add or subtract, I look and I round it to that place value. So I have to end in the hundredths place. So the answer ends up being 17 point. Well, since I have to end here, I look at the very next number to tell me, does this round up or does it stay the same? Well, 8 is above 5. So 5 and up you round up. So this is 17.01 grams. That's the final answer with the correct sig figs. The vertical direction, what you do is you kind of draw a line. Once you go to the end of a number, that one ends there, that one ends there. You go to the short one and you draw a straight line down. And that shows you where it's got to end. It's got to end to the left of that line. So you look at the next number to figure out if you round So it's 17.01 grams. That works for both adding and subtracting. Okay? All right, now what is the area of a piece of paper? So here we're going to be talking about multiplication and division. So in this one, you look for you count sigfigs. And you look for the least number of sigfigs when you're adding and when you're multiplying and dividing. So what is the area of a piece of paper that's 11.5 centimeters long and 5.5 centimeters wide? So we have to recall the formula for an area. Area is length times width, right? So that would be the formula. And now we put the numbers in. 11.5 centimeters times 5.5 centimeters. And we multiply it out. Okay, I don't know that off the top of my head, so I'm going to pull up the calculator and multiply it out. Hold on. Okay, I wrote answer 63.25. Now, what's the unit? We got to remember this. Please remember this. You're multiplying, so it's centimeters is the unit and centimeters is the unit. Centimeters times centimeters is centimeters squared. Just like x times x is x squared. You have to multiply the units. All right, this is what I call the raw answer. Just like this up here, this was the raw answer. It's not the final answer. I got to figure out sig figs, so I count the significant figures. This number has 3 significant figures. This number has 2 significant figures. So I'm looking for the least number of sig figs. Well, 2 is smaller than 3, so my answer has to have 2 sig figs. So 1, 2. You always come in from the left and count. 1, 2. So the answer is 63. Because I look over here, that's a 2. I'm going to round down to 3. So 63 centimeters squared. So whenever you multiply and divide, you always count the significant figures. Okay, now let's do a couple of problems. This says seat practice problems, and it's not mixing up the operation order yet. So we're just doing simple. These are all adding. This is only subtracting. This is dividing. I'm going to give you a clue on this one. We're dividing grams by milliliters. The unit cannot be simplified. The unit for this is just grams over milliliters. Grams over milliliters. And then here we're just multiplying. So pause the video right here, and then I would like you to try these problems. And then once you've gotten them all tried, start the video back up and check your answers. Okay, so let's double check. I haven't written the final answers yet. I have all the raw answers. And this is multiplication. So that's 3 sig figs, 4 sig figs, 2 sig figs. Leading zeros are losers. Okay, first letter A. I underlined where the significant figures end. And remember, decimal points, you come in from the Pacific. This is the raw number, so we look for the least precise. This goes to the hundredths, this to the tenths, and that's to the, that's the thousandths, the tenths and the hundredths. The tenths is the least precise, so it has to end in the tenths place. So I have to round to this spot right here. So it's 45 point, and I look at the next number, and the next number is a 5. That means the 0 is going to round up to a 1, 45.1, and the unit is grams. And it's grams because we're adding, we're not multiplying. So we looked for the least precise. Least precise. Now, even though this number 3.2 has 2 significant figures, in addition and subtraction, look for least precise, which is basically the the one with the smallest number of decimal places, or goes to the largest place value. It doesn't go down. And then multiplication and division, you count sig figs. So you want the least number of sig figs. Okay. All right, so letter B, I added it up. I got 268.5. The precision on this one is only to the hundreds place, the tens rather. Ones, tens, the tens place. That 0 is not significant because we come in from the Atlantic. and we'd cross over that 0, and we'd count 2 sig figs in this number. So this one is only significant to the tens place. This is significant to the tenths place. So I have to end at the tens. That's the least precise. I have to end where the 6 is. So I'm going to look at the next number next to it, an 8, and I'm going to round that, and it becomes 270 milliliters. Now look at that. That's weird. That's really weird. This first number is 270, and my final answer is 270. Well, that's because the instrument I'm using is not good enough to get down below that. And so sometimes this is going to happen. Sometimes your answer will be the same as something in there. It doesn't happen very often, but sometimes it does. Next one, I divided, and there's the unit. I put it way out there. Now, because I'm dividing over here, I count sig figs. This first number has 4 sig figs. This second number has 3 sig figs. So my answer needs the same number of sig figs as the least number. And the least number is 3. Well, I got 2.5. That's only 2 significant digits. I need 3 significant digits. So I add a 0. I'm going to move this way over here so it's stuck close to the unit. It's 2.5. That's only 2 sig figs. I need one more, so that means I can add the 0 at the end to give it 3 significant digits, or 3 significant figures. So that's the answer to that one. And then lastly, I'm multiplying, and I already counted the sig figs for each number, 3, 4, and 2. There's a leading 0, and leading zeros are losers. And so here's the raw answer, and 2 is the smallest number of significant figures. So I count 1, 2 significant figures. I need 2. I look at the number right next to it. That's 6. That's greater than 5. So I round the 1 up to a 2. So it's 7.2. But what is my unit? Okay. We have centimeters times centimeters times centimeters. That's the same thing as x times x times x, which would be x cubed. So centimeters times centimeters times centimeters is centimeters cubed. So that's the answer there. Okay, that's the end of the notes for Chapter 3C. Let's go ahead and look at the Prezi for a moment. Here's 3C's Prezi, and there's density, and it's showing you the difference in the two densities. I'm going to go ahead and make this number bigger. Now, what I really want you to see here is I have a lot of videos for you to look. You can go into your Prezi, click these videos. There's addition and subtraction with sig figs, multiplication and division with sig figs, scientific notation and significant zeros, scientific notation and sig figs, adding and subtracting with scientific notation, and then some more practice problems. All these are there to help review the concept. We will review in class as well, but I want you to be aware of what's here for that. And I think that there's another thing right here. Let me see if I can get to it. I'm going to click on this link. Nope, that's not what I want to do. I don't want to listen to any of these videos. I'm trying to get it towards the end of this. Okay, so it went a little too far. There it is. Let's see if this link comes up. It's looking promising. Oh, there it is. So this gives you significant digit rules, okay? And you can see how long and laborious they can be, but it does talk to you about them. So here it gives you an example of rounding and estimating one significant digit. It talks about trailing zeros only are significant if there's a decimal point, which you don't have to worry about all these if you know the Atlantic Pacific rule. What zeros are discussed. So there's the leading zeros, exact numbers. So anyway, you can go back and look at this if you need more information about sig figs. All right, and then from there, that moves to the orderly problem solving, which will be covered in the next chapter. I will do some more practice with you in your notes. Whoops, not that. There we go. When we have class together or in another video. So I'll see you soon.